A man in a park throws a small ball and his dog catches it with his mouth. The man throws the ball from a height of 1.6 meters and the dog catches the ball at a height of 0.7 meters. The man throws the ball with speed 15 meters per second at an angle of 30 degrees above the horizontal. Question A. Calculate the horizontal distance covered by the ball during its flight. So this situation looks like this. It is thrown from a height of 1.6 and its trajectory is what? It's a parabola, and it flies up to a height of 0.7 meters, and the initial height is 1.6, and you can see that what? Vertical displacement is negative 0.9. Negative because y direction is upwards, and if we consider with respect to y direction displacement, it's a vector, it is negative 0.9, and we know that in general displacement is what? Ut plus at squared over 2, and it's a vector equation, should be considered in components or in projection on corresponding axis. And since we know that vertical component is negative 0.9, and if we consider this equation in projection on y-axis, we can find time of flight to attain the corresponding the final point, and then applying the same equation but in projection on x-axis, we can find this required distance traveled in horizontal direction. So vertical displacement is ut. U it's what? It's the vertical component of the initial velocity, and since it is thrown with speed of 15 at angle of 30 degrees, and vertical component it's 15 times sine of 30, so it's 15 times sine of 30 degrees t, and acceleration due to gravity it's always downwards and y is upwards, so component is negative, so it's minus 9.8 t squared over 2, and is equal to negative 0.9, and hence we can find time of flight. And then if you know time of flight, you can find the required horizontal distance, and you can see that it becomes a quadratic equation, so it becomes 4.9 t squared minus sine of 30 is 0.5, so we can write directly 7.5, and I move everything to the right. T minus 0.9 is 0, and I will apply discriminant, so discriminant is b squared minus 4 ray c, but c is negative, so plus, and then time is negative b plus minus root d over 2a, which is 9.8. So let's calculate the value of a discriminant. So it's 7.5 squared and plus 4 times 4.9 times 0.9 and the square root of the answer is this. And you can see that we should take plus, because if you take minus you get that time is negative, which is impossible. So plus root d over 2a, and it becomes 7.5 and then divided by 9.8, so it's 1.642 and so on seconds. It's not the final answer, so I will not round it, and it's the required time of flight. And then if we consider the same equation for displacement, but in horizontal components or in projection on x-axis, it becomes as is x ut, but horizontal component of the initial velocity, and it's 15 times cosine of 30 times time, and plus at squared over 2, but g is perpendicular to x-axis, so its component is 0. And you can see that motion in horizontal direction, it's a uniform motion. It means with constant speed, and it's always true because g is always vertical, and it becomes 15 times cosine of 30 times this 1.642 and so on, and we get the required horizontal distance covered by the ball. So just multiplied by 15 times cosine of 30. It's 21.3 or just 21 meters, and you should check there must be degree mode, not radian. And question B, find the greatest speed of the ball during the flight. So horizontal component of the velocity, this 15 times cosine of 30, it's always the same, it's always constant at the greatest height and also at the final point. But vertical component of a velocity, it is decreasing initially up to 0, and then it changes sign and increases by magnitude. So the greatest value by magnitude, it will be at the final point, and this vertical component of the velocity at the final point should be found. And then the resultant velocity vector, you should apply parallelogram rule to add two vectors. It's this vector, but we need speed. Speed is magnitude of this velocity vector, and just applying the Pythagoras theorem, it will be what? Just square root of the sum of squares of horizontal and vertical components of the velocity. So what is formula for velocity? Velocity, it's what? U plus 80. It's also a vector equation and should be considered in projection or in components on corresponding axis. And if we consider vertical component of velocity, it is equal to the vertical component of the initial velocity, which is what? 15 times sine of 30 and minus 9.8 t. But again, we need this point, and time of flight is this, so just substituting this time, we get that y is 15 times sine of 30 minus 9.8 times this 1.642 and so on, and it is equal to it's again 7.5 minus 9.8 times 1.642 and so on, and then it's negative 859 and so on meters per second. And then the required speed is the square root of 15 cosine of 30 squared plus this 8.59 and so on squared, and it will be the greatest speed, the required, the greatest speed. So answer squared plus 15 times cosine of 30 and also squared, and then square root or just to the power of a half, and we get 15.6 or 16 meters per second, and it's the required, the greatest speed. And that's all for this question.